Hello, ladies and gentlemen. I hope everyone is doing well today. Today we're taking a look at average atomic mass. Average atomic mass is found in our Unit 4 note packet. So, let me just get this pointer out of the way. So, the first thing we're starting with are weighted averages. So, question 1. Question 1 is, before we calculate weighted average, we're going to calculate just a regular average. We're going to do it both for student A and student B. Remember, guys, you calculate an average by adding up all of the individual scores and then dividing by the total. In this case, the total is 5. So you can do that and find your average for both student A and student B. Question 2. So question 2, now we're going to use that average and we're going to try to answer some questions. So, if you know the student's average grade, can you tell their individual test scores? So take a look at what you calculated for student A and student B. Just by knowing the average, does that tell you any of the scores of the 5 tests that they took? Question 3. So question 3 is telling you student C has an average of 83, and on on all of his tests, he only got 2 grades. The first grade was a 65, the second grade was a 95. You need to decide which score occurred more often. So to help you out, I'll tell you right now that the answer is 95. 95% occurred more often. What I want you to think about is why. Question 4. So question 4. So this time it's asking you to calculate a weighted average. It tells you that each test has a different percentage in the final grade. It tells you that test 1 has a 10%, test 2 has a 10%, test 4 is 30%, and then test 5 is 40%. So when you're calculating a weighted average, there are a few steps. I'll write the steps out later on the next one because it's going to be directly related to average atomic mass. But the first step that you're always going to have to do is you are going to have to convert your percents into decimals. Remember, we do that by dividing by 100. So this becomes 0.01. Remember, guys, dividing by 100 is the same thing as moving the decimal 2 to the left. So if that's easier for you, you can just move the decimal 2 to the left for each problem. After you figure out your decimal, you need to multiply the decimal by the test score that you see in the table up top. So you multiply the 0.1 by 95, the the second 0.1 by the second test score 74, the third one by 82, the fourth one by 92, and the last one by 81. When you solve for these, you find the answers 9.5, 7.4, 8.2, 27.6, and 32.4. The last step when you are calculating a weighted average is then to add all of these together. Once you add, you find that the answer is 85.1. One thing that I want to point out is once you get your answer after you add, you do not divide. You do not divide at the end. We already took into account the percentage that each score equates to in the final average when we multiplied. So you do not divide at the end. So next, we'll move on. So now we're going to move on to calculating the average atomic mass. So on the periodic table, you'll find the average atomic mass for the element. So remember, this mass on the periodic table is the weighted average. It tells you the average mass of all of the isotopes that exist for that given element. Remember, guys, the only difference between isotopes is the number of neutrons. So effectively, when you have isotopes of an element, the only thing that's changing is the mass number because the neutrons are changing. So just remember that, guys. Remember that the periodic table also doesn't tell you the mass of individual atoms. It tells you the average mass of all of the atoms that exist. So don't be confused by that mass on the periodic table. That mass on the periodic table is the average mass of all of the isotopes, not just one of them. So, like I said, I would write down a few steps to help you. So these are essentially the same steps we just did to calculate the weighted average of student A. However, now we are just correlating these to a weighted average atomic mass. So the first step will be to convert your percent to decimal. Remember, we do this by dividing by 100. Then the second step will be to multiply the decimal by the corresponding mass. Then step 3 is to add the products together. Remember, you don't divide, and then remember to include units on your final answer. So the first thing we will do is we will convert all of our decimals, all of our percents to decimals. So what you see me do right here is I am moving the decimal place and the percents to the left. So the first percent becomes 0.951. The second percent becomes 0.0027. And then the last percent becomes 0.0922. The next step is to multiply by the mass that we have in the problem. So it tells us that the 90.51%, which we changed to 0.9051, corresponds with the 19.992. So we multiply by 19.992. The next one, the 0.27, is associated with 20.994. And then the last percent correlates with 21.991. So guys, I forgot to get these answers before, so really quickly, I'm just going to throw my calculator up here. 0.9051 times 19.992 is 18.09. The next one, 0.002, whoops, times 20.994. That comes out to 0.056. And the last example, 0.09. Well, clear it. 0.0922 times 21.991 is 2.03. Remember, guys, the last step is to add all of these products together. So I can't write it the same way I did on the other problem because I don't have as much room. So we do 18.09 plus 0.056 plus 2.03. So then we can do that. 18.09 plus 0.056, 2.03, and that gives us an answer of 20.176 grams per mole. Do not forget your unit. Your units are grams per mole. I will be looking for those on answers, and we will lose points if you forget it. Question 6. Question 6, you need to recreate the same steps that I did, just this time you are calculating the average atomic mass for chlorine. Question 7. So remember, guys, we couldn't compare masses on the periodic table before because we were looking at individual isotopes. When we are calculating the average atomic mass will be very, very close, very similar to the mass on the periodic table. So whenever you calculate average atomic mass, you can compare your answers to the masses that are on the periodic table. Question 8. So question 8 is just calculating another mass. Question 9. So question 9 can be a little tricky. So question 9 is very, very similar to question 3 that you answered. So we know that the 95% in question 3 occurred more often because it's closer to the 83%. So, in question 9, we can look at our periodic table. We can look and see that the mass of phosphorus is. So the mass of phosphorus we find right here is 30.974. So remember, this number is a percentage of these three masses. So which mass is it the closest to? Just like in this problem, just like in question 3, the answer was 95 because 83% is closest to 95. What number is 30.974 closest to? That's the mass that contributes the largest percentage of all of the isotopes. I hope this helps. If anyone has any questions, remember to circle it and write down where you got stuck. So if you get stuck on some of the math problems like 6 or 8, make sure you attempt the problem and you at least can tell me which step you got stuck on when you're trying to go through these steps. You will not get credit if you leave questions blank. Like always, I will try to end these with a joke. What kind of tea is hard to swallow? Reality! I hope everyone has a wonderful day. I will see you guys next class. Bye.